Let me start with a clear definition. Azure Active Directory, now officially called Microsoft Entra ID, is Microsoft's cloud-based identity and access management service. Think of it as the gatekeeper for everything in Azure and Microsoft's cloud ecosystem. When a developer logs into the Azure portal, that authentication flows through Entra ID. When an employee logs into Microsoft Teams or Outlook, that is Entra ID. When your application needs to verify who a user is, it uses Entra ID. Microsoft rebranded Azure AD to Microsoft Entra ID in 2023 as part of a broader security product family. The functionality is identical, it is the same service with a new name. You will see both names used interchangeably in documentation, tutorials, and the portal itself for years to come. The key thing to understand is that every Azure subscription is linked to an Entra ID tenant. A tenant is your organization's dedicated instance of Entra ID. It holds all your users, groups, applications, and policies. Your organization gets one tenant, and everything identity-related in Azure flows through it. This is where many developers get confused. Azure AD and traditional on-premises Active Directory sound similar, but they are fundamentally different products. Traditional Active Directory has been the backbone of enterprise Windows networks since the late 1990s. It manages computers joined to a domain, group policies that control those computers, and authentication using Kerberos and LDAP protocols. It lives entirely on your own servers inside your network. Azure Active Directory, or Entra ID, is a completely different product built for the Internet and cloud era. It uses modern protocols OAuth 2.0, OpenID Connect, and SAML. There are no domain-joined computers, no group policies for OS management, no Kerberos. It is designed for authenticating web applications, APIs, and cloud services. These two products do not replace each other. Most large enterprises run both. Azure AD Connect is a tool that synchronizes user accounts from your on-premises Active Directory into Entra ID. This gives employees a single set of credentials. They use the same username and password to log into their office computer and into Azure, Microsoft 365, and your cloud applications. This is called hybrid identity. Entra ID manages several different types of identities, and knowing the difference is essential. A user is a human identity. Your employees, administrators, and developers each have a user account in Entra ID. Users can sign in interactively. They type a username and password, or go through multi-factor authentication. A group is a collection of users. Instead of assigning permissions to individuals one by one, you assign permissions to a group and then control membership in that group. If a new developer joins the team, you add them to a group and they automatically inherit all the right permissions. When they leave, you remove them from the group. A service principal is an identity for an application or automated process, not a human. When your application needs to call an Azure API, create resources, or access a database, it authenticates using a service principal. It has a client ID and a secret or certificate. A managed identity is a special type of service principal that Azure manages completely for you. No credentials to store or rotate. We will cover this in detail shortly because it is one of the most important security features in Azure. Guest users are external identities, partners or contractors from other organizations invited into your tenant via Azure AD Business to Business, or B2B. Let me walk you through how authentication actually works in Azure, because understanding the flow makes everything else in Entra ID click. When a user wants to sign into your application, your app redirects them to Microsoft's sign-in page hosted by Entra ID. The user enters their credentials there, not in your app. Your app never sees the password. If the credentials are valid, Entra ID issues a JSON web token, a JWT. This token is a cryptographically signed string containing identity claims, who the user is, what groups they belong to, what roles they have, and when the token expires. Your application receives this token and validates it using Microsoft's public keys. From that point forward, every request your user makes includes this token. Your API reads the token, extracts the claims, and decides what the user is allowed to do without ever calling Entra ID again for each request. This model redirect to identity provider, receive token, validate token is called OAuth 2.0 and OpenID Connect. It is the modern standard used across the entire internet, not just Azure. Microsoft provides the Microsoft Identity Platform with SDKs for every major language and framework, making integration straightforward. Role-based access control, or RBAC, is how Azure controls who can do what with your resources. Understanding it deeply is essential for both security and day-to-day Azure management. Every access decision in Azure comes down to three things. First, a security principal who is asking. This is a user, a group, a service principal, or a managed identity. Second, a role definition. What are they allowed to do? A role is a collection of permissions, like the ability to read storage blobs, or the ability to create virtual machines. Third, a scope. Where does this permission apply? The scope can be at the management group level, the subscription level, a resource group, or a single specific resource. The three most commonly used built-in roles are owner, which can do everything including manage access, contributor, which can create and manage resources but cannot grant permissions to others, and reader, which can only view resources. The golden rule for RBAC is the principle of least privilege. Only grant the minimum permissions needed for the task. Give a developer contributor access to the dev resource group, not the entire subscription. Give an application read-only access to the specific storage account it needs, not contributor access to everything. When you want your application, a web app, a mobile app, a background service, to use Entra ID for authentication, you register it. This is called an app registration. Registering an application in Entra ID creates two identifiers, a client ID, which is publicly visible, and your tenant ID. These tell Entra ID that your specific application exists and is allowed to request tokens. For applications that run without a user present, like a background service or an API, you also create a client secret or upload a certificate. The client secret is like a password for your application. It uses the secret to prove its identity when requesting tokens. Important note: treat client secrets like passwords. Store them in Azure Key Vault, not in code or source control. For web applications where users sign in, you define redirect URLs. These are the URLs that Entra ID is allowed to send the authentication call back to. This prevents attackers from redirecting tokens to malicious sites. If you are building an API and you want other applications to call it securely, you define API scopes in your app registration. Other apps then request those scopes when getting a token, and your API validates that the token includes the required scope. This is one of my favorite features in Azure and one of the most important security improvements you can make to any Azure application. The problem managed identities solve is this: traditionally, if your web app running in Azure App Service needed to access a database or a storage account, you had to create a service principal with a secret, store that secret somewhere in your configuration, and remember to rotate it periodically. Secrets in configuration files are a constant security risk and management burden. Managed identities eliminate this problem entirely. You enable a managed identity on your Azure resource, say your app service or your virtual machine. Azure automatically creates a service principal for it and manages all the credentials internally. You never see a password. You never store a secret. You never rotate anything. Then you grant that managed identity the appropriate RBAC role on the resource it needs to access. Your code uses the Azure SDK to request a token for the managed identity, and Azure handles everything behind the scenes. System-assigned managed identities are tied to a specific resource and deleted automatically when that resource is deleted. User-assigned managed identities exist independently and can be assigned to multiple resources, useful when several services need the same permissions. Use managed identities instead of client secrets whenever possible. It is not just convenience, it is a security best practice. Passwords alone are not enough security for cloud resources. Azure provides two powerful tools that go beyond basic authentication. Multi-factor authentication, or MFA, requires users to provide a second proof of identity beyond their password. Azure supports the Microsoft Authenticator app where users approve a push notification on their phone as well as SMS codes, phone calls, and hardware security keys. Enabling MFA for all users in your tenant, especially administrators, is one of the single most impactful security decisions you can make. Microsoft's data shows that MFA blocks over 99% of automated account compromise attacks. Conditional access takes security further. Instead of just asking whether you know the password, it asks whether the conditions of this login are acceptable. You define policies like, only allow access if the device is compliant with company policy, or only allow access from approved countries, or require MFA when the sign-in risk level is detected as medium or high by Microsoft's threat intelligence. A practical example, you create a conditional access policy that says if a user tries to log into the Azure portal from outside the United States, require MFA and block access from anonymous IP addresses. This adds a meaningful layer of protection without interfering with legitimate users doing their normal work from expected locations. Everything we have covered so far is about identities for your employees and developers, the people inside your organization. Azure AD B2C is for a completely different audience, your application's end customers. If you are building a consumer-facing product, an e-commerce site, a mobile app, a SaaS platform, your customers need to create accounts, sign in, and manage their profiles. You do not want to put those millions of customer accounts into your corporate Entra ID tenant. Azure AD B2C is a separate service specifically for this. Azure AD B2C handles the entire identity journey for consumer users. Sign up with email and password. Sign in with Google, Facebook, Apple, or any OpenID Connect provider. Password reset via email. Profile editing. All of these flows are fully customizable with your application's branding. The sign-in page looks like your product, not a Microsoft page. B2C scales to hundreds of millions of users globally. You pay per monthly active user rather than a flat rate, which makes it cost-effective for consumer applications that grow over time. The key distinction, Entra ID is for your internal workforce employees and partners. Azure AD B2C is for your external customers, the people who use your product. They are separate tenants with separate configurations. Let me close with a summary and the mistakes I see developers make most often with Entra ID. Microsoft Entra ID is the identity foundation for everything in Azure. Users, groups, service principals, and managed identities all live here. RBAC connects those identities to permissions on specific resources. App registrations let your applications participate in this identity ecosystem. The most common mistakes. First, assigning owner role too broadly. I see teams give every developer owner access to the subscription because it is easier than thinking about permissions. Owner means full access, including the ability to give others access. Use contributor for developers and restrict it to the resource groups they actually need. Second, storing client secrets in source code or configuration files. Use managed identities instead. If you absolutely must use a client secret, store it in Azure Key Vault, never in a repository. Third, not enabling MFA. If your Azure admin accounts do not have MFA, your entire cloud infrastructure is one phishing email away from being compromised. Fourth, confusing Entra ID with on-premises Active Directory. They share a name but are different products with different protocols and use cases. In Topic 6 we cover Azure Resource Manager, the layer that sits between you and every Azure service, processing every deployment and management operation. Understanding ARM is what makes Azure's consistency across services click. See you in the next video. Here is your knowledge check for Topic 5. Pause the video now if you want to think about it yourself. Your app service needs to read files from Azure Blob Storage. What is the best way to authenticate without putting any passwords, secrets, or connection strings in your code? The answer is Managed Identity. You enable a system-assigned managed identity on the app service. Azure creates and manages a service principal for it automatically. Then you grant that managed identity the storage blob data reader role on the storage account. Your code requests a token using the Azure SDK with 0 credentials stored anywhere. This is always the right answer for Azure to Azure authentication. No secrets, no rotation, no risk of credentials leaking. See you in topic 6.